Good evening and welcome everybody. My name is Obi-Wan Pez and this is N Simplex Pachinko, and tonight we are doing our probably last night of differential equations. We'll see how things go. We have with us our two co-hosts and guests, Zach at e to the 2i pi and enstucky. If you would like to introduce yourselves, go for it.
Greetings, chat. This is you all know me, I think, but I'm Zach, and I've been helping out with the class and enjoying every moment I can be here.
Yeah, good to have you here. I'm Ian Stuckey over at I stream over at Twitch as well as host a Substack. And I didn't know this was getting close to the end, so I'm excited to see what happens.
Yep.
I didn't know when I actually didn't know when you were going to call it quits. Like I mean, or like whatever when the ending was going to be, right?
So like we're at the end of my actual list, my actual stuff. So I did have like a couple of other topics we could go into, but at the same time, like I'm not feeling 100% confident with them, so we could see where things end up.
Cool.
And as always, I'm going to be here on Tuesday nights anyway for all of our regular math stuff, so if anybody does want to see random other differential equations type things, we have nonlinear, we have partial, we have numerical methods. There's all sorts of books that I have over here from one of my friend's fathers who is retired. That collection was something else, I gotta tell you. Alrighty, so with tonight, let's see, is this working? Cool. Me Machine Rex, thank you.
Hey, machine.
Welcome on in.
Before we get too into it, we will get slightly distracted. So, as is the case, we usually do a reading out of Main Lingo, a wicked good guide to Yankee vernacular. And apologies, I am a little, I do have a bit of a tail end of a cold that I'm working on, so I will cough occasionally, more than usual. So we'll try to make this work. Alright, tonight we're going to go with J. The official word for this one is jackass brig. Jackass brig is a cross twixt a brig and a schooner, square-rigged forward. Also called... Can't read that word. Also called a blank brig, except that Maine people pronounce it Moffodite. Jackass brig could be worked with fewer hands, and in this economy made them popular. In time, jackass brig has become jackass rig, and this term is used today for anything not conforming to type, or something offbeat, if you will.
I never thought to ask. That's really interesting.
Of course, I don't know. This was written in like the latest publication was in like the 90s or something, but the original copyright's 1975. So who knows what's still in use today? But at the same time. Okay, so
What was the name of that book, by the way?
Main Lingo.
Lingo. Okay.
By Down East Books, a man by the name of John Gould, who the author's biographical information in the front said he was born in 1908, so we can probably assume that he's passed. I imagine it was probably sometime in the 90s. There we go.
And now you've got me engrossed in Maine slang. I'm just looking up some stuff as you're chatting about it. I thought this was interesting.
No, as a reminder though, 1908, yeah. As a reminder, we do, or I try to hype a project from the 1970s called Bert and I, B-E-R-T. Which was a project done by Marshall Dodge and Robert. I always forget his name. That's terrible. Robert Bryan and Marshall Dodge. So their project, Bert and I, was intended as a storytelling, kind of capturing the storytelling of Down East Maine, which is that section of Maine that kind of juts out a little bit to the east before going back straight north, pretty much again, around the area of Bar Harbor, or Bahaba, as you would have it. They heard about the unique storytelling style when they were in college at Yale, and then the two of them went up there and discovered that, oh my god, these people were not lying. All of their, college roommates and people that they met around town, they're like, nobody talks like that, come on. And they're like, no, you've got to go see it for yourself. And they did. Bert and I was performed at the Stratham Fair, which was in my town of Stratham, New Hampshire. When I was living there, we moved around. And I developed a liking for it. My dad bought all of their tapes back when tapes were a thing, and I bought the CDs probably last year sometime, and I forgot. The version that I have is kind of a condensed best of. That's not the whole thing, but anyway. Oops. It's fun, and I do like to hype Bert and I because it really does have a lot of study behind it. It's really cool. If anybody is interested, you can go look that up, or there are also, I'm sure, some sort of project similar to it for your particular area of the United States or elsewhere in the world, for the particular language, the particular storytelling style, and the particular vernacular that exists for your area. It might be an interesting project to look it up, and perhaps even take down some notes if you find that there isn't one. Okay, so for tonight, we're going to talk about this guy here, Oliver Heaviside. That is actually his name. And... let's see, 18, yeah. If anyone was to be a math Chad from the mid-1800s, this guy's it. Quite the dapper guy. Oliver Heaviside was born in 1850. Ended up having a bout of scarlet fever when he was young, which left him with a slight hearing impairment. And then he went on to revolutionize differential equations. And also, what was it? He independently developed... Oops. He independently developed vector calculus, and then rewrote Maxwell's equations in a tighter form, which is the ones that we know nowadays. So if anybody is aware of the Maxwell equations, it kind of is usually referred to as the Maxwell Heaviside equations. And the technique for solving differential equations that he developed ends up kind of working into the Laplace transform, which is what we were dealing with last class, 1 week ago. Looks a little like Max Planck. So, the specific idea that he developed was to come up with a better way to work out our forcing functions. And specifically turn them into what we know as impulse functions. So they're also called impulsive, and they're also piecewise functions. So we can talk about that in just 1 second. Sorry. Oy. All right. So in impulse equations, typically what we're talking about is we take some sort of function, whatever it might be. I don't know if I want to call it I necessarily, but it's going to have some sort of, let's do that second. Some sort of functional representation, f of t, and otherwise it's going to be 0. So typically we're going to see 2 domains over which these exist. It's going to be our standard piecewise function, but whatever it's going to be. This is going to go from negative infinity to some, let's say, a, and union, I made him too big. B to some infinity, where our function f of t is going to go from a to b. Now, I'm not terribly picky about where the open and closed brackets are going to be, just because, again, this is going to be like every other integral that we're doing. The integral at like a specific point is going to be 0, so it doesn't really matter what you do with it. What really matters is the cumulative effect of an entire region, so an entire interval being summed up. All right. Anybody have any questions, concerns, stuff you want to bring up?
Not at this time.
Good so far.
Now, this is terrible notation in terms of being able to actually do anything with it. So when we go back to an example that we had last class, I'd said that a particular function was going to be zero when t is less than some c value, and 1 when t is greater than or equal to some c value. So this was an example that I think, Stucky, I brought up. I think I brought it up before you left, where we said we were just going to do it as 1 for all time, and then we were going to make it a little more interesting now. So in terms of doing this particular one, Heaviside said, all right, what we're going to do is we're going to say this I of t, our impulse function, is going to be shortcut as u sub c. Because this is a unit function, it is a constant, and it's either 0 or 1, and then it changes at c, our particular c value. So u sub c is just going to be the same definition that we had here for that particular I of t. And then if we were to graph this, this is going to be for all time up until whatever our particular c is. We're going to leave it open there and closed at 1. It's going to be 1 for all the rest of eternity. Okay, so this works really nicely with our forcing functions, especially if they're constant. We're going to be able to see that we can have any number of representations for this particular thing. There are 2 major representations for it. If I of t is equal to -1, 3, 5, and 2 between the intervals 0 and 2, 2 and 6, 6 and 8, and t greater than or equal to 8 respectively. Would you be able to do the unit representation of this particular function? Yeah, sorry. Do the u representation for this particular function.
Sure.
There is a slight implication that I didn't mention, and that is that I of t is going to be equal to 0 for t less than 0.
Enough. Well, we could say that like the UC is like turning on at the point C. So we think about it's changing. And we're going to get a C for each of those change points. So U of 0 plus U of 2 plus U of 6 plus U of 8. And then we have to figure out how much we're changing. So the first one is going to be, we go from 0 to -1. So down 1. The next one we go from -1 to 3, so we go up 4. Then we go up 2 to get to 5, and then down 3 to get to 2.
All right. Zach, commentary?
I like that. The thing that gets people, I think, when writing these, and like Stuki, you did that so quickly. Sometimes I like to draw pictures, but I was I was looking at that, and I think it's the cascading effect is what often gets people. when I've seen that you have to think about for the section from 6 to 8, because you flip a switch on past 2, you have to think about the section from 2 to 6 and from 6 to 8. Like those overlap and the 0 to 2 section as well. So you have to account for all of those constants in the 6 to 8 section, which Stuckey so effortlessly did, and I feel like just needs a little bit of emphasis.
Right. I would agree that a graph might help just because visualization is a great way to expand your particular perspective, and maybe somebody else could see it the way you see it, or vice versa. So yeah,
but for the record, I agree with what Stuckey said.
Yes. Alright, so if we got 5. Oh. Always. Every single time. Close enough. Somebody's gonna yell. So anyway, what we have here, right, we're going from negative infinity up to 0. Then we're gonna have an open circle at 0. It goes down to 1. And then we go out to 2, where we have an open circle. It jumps up to positive 3. And stays there for 4 units. Hops up to 5 for 2 units. That's not what I wanted. Hops down to 2. Right. So, again, the way Stuckey did it was, let's look at the hops that were taken for this. How much does it need to change at each of these points? And once you figure that distance out, right, plus 2 here, plus 4 here, minus 1 here, then you're just saying, okay, at this particular C value, we're making this particular move. So again, a minus 1 in the front of U0, plus 4 onto U2, plus 2 onto U6, minus 3 onto U8. All right, Zach, how else might you describe it?
I like this method personally.
Okay.
If I'm honest, I like the way this was done.
Okay, I didn't know if there was another one that you were angling for.
Actually, no. I might have tried to plot our graph, but you did that. And looking at the cascading change, I think is fine. But that's exactly what Stuckey's done. So I have no notes.
Complaints. Yep. Okay, so what would happen if we split these up into their component parts? And specifically, dealing with the function that we're dealing with up top.
Are you saying that you want to just plot each of these pieces separately? That's what I'm hearing. Maybe I'm misunderstanding.
I think
for
so.
instance, plotting, like creating a function that just models the function constant at 3 from 2 to 6, and being able to create a function that models just the constant from 6 to 8, and you get a constant function of 5, and so on.
Let's try that one.
Well, I don't know. Like, is that what you're going for? I just wanted
That
to make
is what
sure
I'm going for,
understand.
yeah.
That's what you're going for. Okay. All right. So what I might do is say, well, so we just need a 3u2. Let's just create that second one. So if we create the function from 2 to 6, I'll need a 3u2. In practice, all that does is turn on the signal, if you will, and then I would need to turn off the signal at 6, which means that I'd need to have a -3 u6, and that would give me the line segment between 2 and 6. The switch method. That's how I think of the on-off switch, right? I'm turning something on or turning something off.
I like to think of those big giant power switches, for the fuse switches from the 1800s.
Sure.
Of course.
So yeah, what we've got here then is we're taking our, -1 at the very beginning, and we're saying that we want to turn it on at u0. And then in order to turn off this thing, it needs to do what?
Wait, so are we just doing the first two? Is that what we're going for?
We'll get there eventually, but...
So I thought we were just talking about just that middle line segment. But if we're talking about more, I just...
Well, the whole function altogether. So with the whole function, all of it ends up being either we've got a change method, in which case we're looking at the change between each segment, or a switch where we're throwing switches, and in order to in order to get the next... Yeah, go ahead.
I think I see sort of where this is going now. So in other words, you'd have a -1, but then after you need to eventually turn that back on at 2 units, right? So I'd need to, I want to have after 2 seconds, if you will, I need to turn on this thing by putting a plus u1 or u2. I mean, I need a plus u2 because that will reverse what happened before.
Yep.
And I think I'm starting to see what you're going for. So, and then we can continue, because once I've turned off the 3 at u6, then I need to add on 5 at u6, because that will turn on the 5 switch, if you will, from 6 to 8. And then we can subtract 5u8, because that will again bring us back to 0. We turn off that switch and turn on the 2 switch at 8.
Right. So, ridiculous as it is, right, we could also just see how they're grouped by each of the u functions. We're saying that our, at the end, our -3 here is splitting into a -5 and a +2. In that, we're turning off our 5 at u8, and we're turning on our 2 at u8.
Right.
And likewise for the others. So our 2 here is a -3 and a 5, our 4 is a +1 and a +3, and our -1 is just by itself. So it's just that one. Okay, so in doing that, this then allows us to say, okay, but let's suppose, for example, that this is a much more complicated function like a cosine. Right? If my u0 is cosine and my u2 is I of t equals 3, I don't really want it to be like... I'm not going to want to worry about the change, necessarily. Because that's going to mean that if we did it with the change method, with a cosine function, right? This is going to be like cosine of t, u0. And then when over on the u2 side, we would need to have a negative cosine of t plus 3. So this can start getting slightly unwieldy if we start doing it in this particular order. I would argue it's probably not going to make much of a difference, but there is the possibility that you're going to come across some sort of example which is going to be a pain, and it's just easier to change it out for the other style, depending on your particular instance. All right. Right, so what if this is more complicated? Again, we're going to get potentially. Right. Right, so we'll come back to that in just a sec. So with the switch method of showing things, we're going to have that I of t is equal to. Over here, we could group this by function type. So our -1 can sit out front, and then what's left on the inside?
That would reverse. I mean, if you for everything, if you're doing this for everything, you just reverse all of the signs.
Right, so -1 is going to be the function that we're using over that particular time period.
Right. So I mean, we could do it like a u2 minus u, u0 minus u2 rather. If
yeah,
that's another thing you could do.
Yep. So then this
Again,
next
modeling
one,
that the on-offness.
Yep. So then the next one's going to be.
Let's see here, a 3 u2 minus u6. So 3 times all of that. And then a 5 times u6 minus u8.
And then just plus 2u8 at the end.
That's right.
So in this switch method, we end up with this cosine stuff that we talked about over here. We could instead have be the cosine of t times u0 minus u2 plus 3 u2 like that. So again, it kind of depends on what you want for your particular method and how you're going to go about solving. Some instances may be easier one way versus the other. It kind of depends on what you got. I don't think I actually learned switch until I started teaching. I think it was always doing it with change. Which, I mean, is essentially equivalent, but you're just grouping them differently. Okay. So Heaviside worked out how to do all of this notation and how to then apply it to differential equations. So if we're going to go with, let's go with the example we had last class. So we're going to go with our 0, 1, and that was at U3 then. And our actual differential equation that we used was y double prime y double prime plus 4y is equal to... I think that's right. Yes. All right, y double prime plus 4y equals 1, for which we had a general solution just of this thing, which was a quarter minus a quarter cosine of 2t. So we can compare how this is going to work. All right, for all t in the, no, just reals. Right, so now we want to know how this is going to change it. This was y equals 1/4 minus 1/4 cosine of 2t. Okay. All right, so how does this work with Laplace transforms?
Well, we got to Laplace transform the whole thing,
I do.
which is conveniently an integral. So anything, all the properties of integrals that we know and love, such as, linearity, is useful here. And you have a nice little table.
Yep.
I
This
recognize that table.
Yes, you do. This is the table out of the Boyce and DePrima book.
I was gonna say, yeah, that's the exact one.
Yep. 10th edition. Woo!
I got my 8th edition on my desk.
We had 6th when I was in undergrad and 8th when I was in masters. And then I started teaching at a 10th. Okay. So with this...
But we can look at the... I think it's going to be item 12 that's relevant for us.
Mm-hmm.
Mostly for the right-hand side. And then... Yeah, we'll take the Laplace transform. And for some reason, the scripty L is just satisfying.
When you can draw it correctly.
When you can draw it correctly, it's just like every time I would do this, I'm like, oh man, it's so weird, but it's oddly satisfying. So, right. So we know e to the minus cs over s. That's going to be the right-hand side. E to the minus 3s over s, rather. Since our c is 3.
Right, so we're looking at, 13, yeah. So it is 12, but it's also 13. Just we're looking at it in terms of, oh look, we're taking a function, we're shifting it. In this case, it doesn't really matter because we don't, well...
Well, we know that the Laplace transform of 1 is 1 over s. That's coming from item 1.
Right. So that's why 12 is technically more relevant. Okay. Good times. So yeah, essentially our f of t is equal to 1s. That gets us our 1 over s. Cool. All right. Now the left-hand side.
Well,
Down a few rows to 18.
18.
We'll get.
Oh, I didn't give initial values. No, I did. Never mind.
No.
Never mind. We got U3. No, wait. No, that's a forcing function. Okay. Sorry. Never mind. Looks like I did this in general, so it's fine.
Yeah. So we'll get the first term is the big one, which is s squared. I don't know what our preferred name for this y gonna be?
Usually big Y.
Big
Big
Y.
Y.
Love it. Minus S time.
Yeah, they were all assumed to be 0 in here. Cool.
Okay.
Nope, not S. All right.
No S term. So
Okay, so just plus cap Y. Right hand side.
Okay.
and then this is fun because now we have the we can factor and have a denominator of S times S squared plus 4.
Yep. So we'll just keep that up top. Never mind.
Sure.
Right. So y is equal to e to the negative 3s divided by s times s squared plus 4. Okay. Now what?
Well, if you want to do this by hand, we do have to go to
Absolutely.
partial fractions, right?
Yep.
So and the other thing here is that since it'd be good to separate out the e to the minus 3s term, which is going to be a convolution in the end. Since we have a product here of e to the minus 3 times something else, that's a convolution. We'll come back to that. But the idea here is to take now the 1 over s times s squared plus 4 and partial fractions that.
And make it.
As what is a over s and bus plus c over squared plus 4.
You didn't fall for the trap.
It's a trap.
Right.
They don't call me Admiral Zakbar for nothing.
Yeah. All right. So why is it that we need this linear term over s squared plus 4?
So s squared plus 4 is irreducible over the reals. So as such, we need to. It's prime. There are no factors in the real numbers that are linear polynomials. That is. So we just account for that by putting the bs plus c in the numerator. That is the degree 1 less than the denominator. The general polynomial degree 1 less.
So we want constants here, in this case a, b, and c, which are going to not divide the lower bits, not divide into the lower bits. And so in this case, we're just looking for what are the a, b, and c constants that are going to make this all work. So yeah, we need this linear term. If you just went with a constant term, chances are you're going to get an answer, but it's not going to be the right answer. It's going to fall short. And somewhere through this process, you'll probably realize, something is wrong here. Chances are. Now, the good news is that when you're working on this, we can also look at our LaPlace transform and say, okay, the denominator is s squared plus 4. That looks an awful lot like our sine and our cosine.
Mm-hmm.
And if we look at the numerator for sine and cosine, we notice that there's an s in one and a constant in the other. So feels like we should have at least, we're giving the equation, capital Y, a chance to have both a sine and a cosine in it at the end. Which, if you remember from our second order differential equations, when we were just solving them with constants on the right-hand side, or even just other functions. Our left-hand side here, our homogeneous solution, has both a sine and a cosine in it because our eigenvalues in this case are going to be complex. So s squared plus 4 has complex roots plus and minus 2i, and therefore those are our eigenvalues. So we're making all these connections. If we have complex eigenvalues, that's going to get us sines and cosines in some arrangement. Occasionally they'll just drop out, right? One of them could have a 0 in front of it. And we don't know if that's the case, but again, we did see earlier that our regular LaPlace transform only had a cosine in it. So that's possible. We don't know exactly how it's going to go, but we'll figure it out. Okay. What was I going to do? There was something up here that was wrong. Not wrong. Maybe it's
This is my cue. I'm going to have to get going.
Okay.
It's 2:45 for me, but I wish you all the best on the rest of today's class. I'll lurk around if I can.
Alrighty.
But thanks for doing this, and I don't, like you say, this is our last one, or are we going to have another one next week?
I think
Okay.
we're probably going to clean up here.
Okay.
Just because I don't feel supremely confident on the next potential additional material that I could have had. But
okay. I was just curious.
Was I feeling well this week? That would have been my project, but oh well.
Understandable. Well, your health is important and very important enough to take care of, that you should take the time you need.
Yep.
So, as grateful as we are for this kind of class.
Woohoo! All right, thanks, Zach.
And by the way, I have to say one last thing. Congratulations on 500 followers. I just noticed you hit that.
Yes,
so
thank you.
Congratulations on that.
Yep, I put the ribbon up for 510, whatever it is, and then we're gonna. I don't know. We'll probably have some sort of celebration on Friday.
Wonderful.
I don't know what we're gonna do,
up.
but you know. Alrighty.
Catch you later.
Night, Zach.
Take care, Zach.
Good afternoon. You know.
Yeah, see you, Dookie. Bye-bye.
Alright, so in this case we want to give our function a chance to have both a sine and cosine, so let's have both our linear be s and our constant c in there to make sure that we have the option. See what happens. Alright, what do we do next?
Multiply through and solve.
Alrighty. Good evening, Govan. How are you? My name is Obi-Wan Pez, and this is N Simplex Pachinko. We are doing some differential equations tonight. I do have typical math help streams on Tuesdays, and we have been doing differential equations on Monday, Wednesday, and we do gaming on Friday. So we'll figure out starting next week exactly what we want to do with our time. Gonna be suddenly opening up some time on Monday, Wednesday.
C0 and 4A.
And Govan, if you want to share your level of comfort or expertise in mathematics, we can let you know who else is available, or what are the resources you might have here on Twitch. Second year math major undergrad, nice.
Cool.
Yep, I've been teaching at a community college in Maryland in the United States for the last 15 years about, and my family just moved to the United Kingdom, so we're hanging out over here 5 hours ahead of where we used to be. Alright, Stookie, what do we find?
Got a quarter and minus a quarter. And 0.
Alrighty. So, what do we do?
Well, let's used to put in the capitals, but okay, so we're gonna get so it's this thing we just solved for, but it also had gross, but which means that YP is gonna be use 17.
I might argue we want to use a different one.
You think so? Is there a better one up here? 14 looks nice. Okay.
Nope. Sorry. I would argue also a different one.
Oh, I see. Wrong side. 13.
Yeah. So on our LaPlace transform side, anybody who hasn't seen this yet, we have a function, which is our capital Y, and this is kind of why we're using capital and lowercase in this particular order, just because our table's doing that. So, like, you know, you don't have to, but at the same time, makes it a little bit easier. So we have e to the negative cs times f of s as our current function, which we are trying to take the inverse Laplace transform of and end up back on the left-hand column. So in that case, we see that we end up with our u sub c times lowercase f, our original function. In this case, we got our y. And that y is also going to be shifted. So we end up with u sub c times y sub, or no, well, no. It's whatever our original function is, f of t minus c. And then we go like this. We get that. Anybody who doesn't know, we're currently using the Discord server of Penn Center, who is another one of our math streamers here on Twitch. He also does, I don't know if I would say specializes in linear algebra, but he does a significant amount of linear algebra. We also have on the line with us enstucky.
Hello.
And we had Zach, who is at e to the 2i pi, just a few minutes ago. Had to get going for something else. And inclusive on the much larger list, we have the Math Chads all currently 7 of us. There are more people who need to be added to that list. We have Don Does Math, Zach at E to the 2i Pi, Penn Center, Ian Stuckey, Obi, that's myself, at N-Simplex Pachinko, Danny Highway, and Dr. Gold at Actual Education. So, that is our wonderful group of streamers who we're trying to get everybody just kind of grouped together and form a larger community. So, the more educational content anybody watches on Twitch, the better off everybody is. So, in more ways than one. All right, so you got 1/4 U3 minus 1/4 U3 times cosine of what's on the inside?
Yeah, so I'm trying to convince myself this should be 2 times parentheses t minus 3, because it doesn't feel good to me that it would be so different from the continuous case.
Mm-hmm.
Not quite feeling it.
So I would agree with you. So the reason is that when we talk about horizontal shifts, we were looking at this as the function itself was getting shifted t minus c, like f of t minus c, and when we do our function a times cosine of b times quantity t minus c plus d, right, this is our horizontal shift. And when we think about what's happening in the situation up above, it would make sense that we're dealing with a horizontal shift of the cosine function because we have nothing going on for all time over here. Our initial velocity and position are both 0. And then suddenly this impulse occurs at, a forcing value of 1, which is going to cause this particular motion. And due to the fact that it causes this particular motion, it's going to then, right, shift it over 3 seconds for when this suddenly starts. Hey Punching, how you doing? So if we go over to Desmos, for example, we can actually type all this stuff in. I don't think it does U notation, so... Alright, if we just did like y equals u sub 0, no. Alright, cool. Just making sure. Alright, so we have, let's do y equals 0. We know that that's going to be true from all time until 0. That was... okay. No. Huh. Okay. Oh, we'll just do it up here. T less than 0? Yeah. Okay, so for us it was actually t less than 3. Desmos will turn your functions into music. I think I saw somebody do a video on that recently, but I haven't actually tried it myself. Okay, and then we said y is going to be equal to, this was 1/4 minus 1/4, oops, cosine 2 times t minus 3. Right, so if we look at where this was originally, our values actually don't quite match up, right? So we've got a value at t equals 3, where our 0 function stops, and then a minimum value at, of course, t equals pi. So that doesn't quite work. So then we shift it over to t minus 3, and now our values line up. So now our cosine function has a minimum at y equals 0 when t equals 3, which is precisely where our other function should end. So now we just have to plug in the fact that this is going to start at t is 3 and be greater than or equal to. Right, and now we get our whole picture where this picks up at 0 and then starts moving as a cosine wave between 0 and, what is this? 0.5, right. Alright. Stuki, do you have any questions that either you or a student might have? Take a picture of that. Of course, if anybody in chat has any questions, let me know. Nope, not documents. Nope, not that one. Panic.
I guess it's reasonable to ask at this point, like, how much we needed to bother with this.
How do you mean?
So algebraically, this e to the s sort of comes along for the ride. Doesn't interact with anything, and then at the very end, it says, oh, by the way, shift your function over by 3, which our intuition was pretty strong that that's probably what we would want to do anyway, because if we just forget about everything happening to the left of 3, it looks exactly like what happens when we forget about everything to the left of 0 in the constant case.
Fair. Right, so when is this actually going to be used without saying the exact question that students ask? But I mean, in this case, it is kind of a fair point, right? When exactly is all of this occurring? So we could, for instance, use a more complicated example. So let's do y double prime minus y is equal to e to the 2t when t is between 0 and 2 and 1 from thereafter. And this time we'll use actual initial values. So y of 0 is going to be 3, and y prime at 0 is going to be -1. Right, so we're at 3 coming downwards as our initial values. Right. All right.
Okay,
We
so my belligerent answer is as follows. This is two different differential equations that we've grafted together, and the thing that we would have to worry about to do this grafting is that the initial conditions on the second equation are going to be determined by, where we end up fiddling around to in the first half.
Sounds fair.
So I'm curious how convinced I am by the Laplace transforms that I want to do that instead of solving the differential equation twice, which I could see that being possible.
Yep.
So let's.
So the other problem is, well, right. So how do the homogeneous and non-homogeneous portions end up working nicely to make that happen? So I guess the forcing functions you're saying are just directly going to change over. And then all we have to worry about is what are the values at the end of 2 seconds for the first one, which we then input as the initial values of the second.
Right.
If I interpreted that correctly.
Yeah.
Okay. Yeah, that's fair. So the other question is, if you were to do this in a computer,
Right.
like how much programming do you want to do?
Sure. And minus. I got very excited here, but probably I want to do some pre-processing on the right side. That's fine. We'll do it later. And then this is y. Just what it is. Okay. Yeah, okay. So since the thing that we have to work with is the unit functions, I want to write it that way. So this left-hand side, or right-hand side, sorry, is equal to, well, start off at the 2t, and then at time 2, we change the alt. Turn off e to the 2t. We turn on 1. Oh, I see.
Yep.
This is maybe a little silly. Let me...
I mean, if you just reverse it, yeah, it... Never mind. It really depends on what you like. That's e to the what?
Positive 2t. Cool. So back to number 13. We're getting a lot of mileage out of 13. So this is U0 is going to translate to e to the 0, so that's great. So that's just going to be okay, so we've got, perhaps we want to do even more processing, but let's get the exponential down first.
So that's also an interesting point.
Mm-hmm.
Is that anything that doesn't have a particular e to the whatever attached to it could be used as u sub 0 when we bring it back.
Anything that doesn't have e to t attached to it could be used as u sub 0. I see.
When we're in LaPlace space. So if you just had like a 1 at the end of it somewhere, that's a bad example. If you just had a 1 over s somewhere that didn't have any e's attached to it in Laplace space, then when you do the inverse Laplace transform, it's just a constant 1, but really it's 1 u0 or at least it's equivalent to 1u0.
Right.
Which is a little bit awkward sometimes, but...
Okay, so I'm trying to graph together a bunch of things on this chart, but I think 1 over s is close. 1 over s minus 2. Because that's exponential. So on this side we've got exponential times 1. The 1 would turn into 1 over s, but the fact that it's exponential means we have to shift over by -2. +2, exponent, -2 shift. Okay, and so now my complaint is, I guess, maybe not relevant quite yet. Okay, so let's just do 1u2. That's going to be e to the -2s over s. Careful. Yeah, I guess that's right. Because we have to shift the time function over, but it's a constant function, so who cares? But in preparation for that, let's write our function in terms of t minus 2 instead. Plus 4.
This is probably one of the things that got me tripped up the most when I was first learning how to teach this, was remembering this little bit. So the problem here is you can't just take the Laplace transform of e to the 2t at u sub 2 and just be happy with it. You have to have this t shift exist within this function first. So if it doesn't exist there, if it isn't there already, you have to make it exist. And in the case of an exponential function, it's super easy, right? We just end up adding in this case, 4 on the end to balance it, and then that ends up just coming out as a constant. So super easy. So there is the possibility that you end up with something in there that is not going to be convenient, and if that's the case, well, I'm thinking something like a natural log, right? Like,
sure.
Me personally, I don't even know any particular. I mean, I guess this would not be the best way to come up with a solution to a non-homogeneous natural log equation. I don't even know if there is one apart from starting to do like a Taylor series representation.
Yeah, how bad does that change of variables get?
With a natural log?
Yeah.
Yeah, you might have to go about it like reverse of what I'm thinking. But yeah, anyway, good times.
Okay, so 13 again, C's to F is F is e to the 2t. So then we get 14 involved. And that's e to the 2t times 1. So that's going to be s minus 2 again.
Yep. I'm going to stop here for 3-minute ad break.
Sounds good.
Going to recommend everybody get up, stretch, go trade out your water as you need to. And we'll be back in 3 minutes. Stuki, if you're good, you can either take a break or keep working, whatever you feel like. So we'll be back in 3.
Sounds good. Yeah, I'll be refilling my water. See you soon. Mhm.
Alright. We're back.
Hey.
It's getting way too hot in here. Alrighty. This evening is hashtag not sponsored by Siren Broken Dream Nitro Breakfast Stout. We got a slight, I won't even call it mishap, pouring malfunction, because it says pour fast, pour hard. I did so, and this will hold 16 ounces of liquid, but not so much the foam. Anyway. Alrighty.
Righty. One. Time.
Alright, what do you notice about some of these?
We got a couple that are similar. Oops. Is that it?
Alright, any specifics?
Like these two, looks like we could save some computation here. But that's it. Yeah.
Yeah, why would that make sense for those two terms to be almost identical?
Probably because they came from the like switchover at the
right
at like 2.
So that corresponded, if we go backwards, right, to our 1 over s minus 2, which came from e to the 2t. So yeah, it makes sense that we're switching it on in the first case here, and we're switching it off in the second case here. They're going to show up directly inside of all this stuff. So definitely we can save some computation and break those into, you know, one case that we're just doing twice, and then say, look, it's just going to be like plus that and minus that. We don't have to worry about finding separate constants. And even if we tried to, they would just literally come back to the exact same numbers, just in reverse.
Right.
All right, what else?
That's all I noticed, except that s squared minus 1 is reducible, so...
Okay, so s squared
more.
minus 1 is reducible. If we break it up, it becomes s plus 1, s minus 1.
Right.
And if
I
we
see.
separate
You're,
those... Yep.
Directing me to look at the table here.
Yes.
Yeah, okay. So we have the hyperbolics, which allow us to not break up
Right.
the
So
quadratics.
we could kind of choose at this point. Do we want to split it up as s squared minus a squared? And then we could just use the s squared minus 1 as it is to get a linear combination of hyperbolic sine and hyperbolic cosine. Or do we want to break them up as s minus 1, s plus 1, in which case now we've got e2 plus and minus 1 as two separate individual exponential functions. Which, anybody who doesn't know, Stuki, do you want to explain?
Oh, what hyperbolic sine and cosine are?
Yeah.
Is that what I'm?
Yes.
They're
Approximately. You don't have to have 100%.
yeah, they're shorthands for a nice sum of exponentials, which is, I don't know, something like this-ish. Okay, thank you for that. Maybe positive x over 2 over 2. I don't know. The 2's are maybe a little weird, but things that look vaguely like this.
So I think it's just x when the interior portion is just x
nice.
as well. Yeah, because in this case it's a is 1, so that, yeah.
There's some analogy here, right? If you trade off those x's for I times x's, we got Euler's formula, and the ordinary sines and cosines pop out.
Right.
There's a lot you can say about the analogy here, but not a bad one.
Yep. There's some really cool stuff. If anybody wants to look into more about Euler's formula, I think the initial proof of Euler's formula that I saw was in Calc 1. I don't remember exactly how it started.
Calc 1.
Yeah, we did something in Calc 1 that made it pop out, and I swear I could have done it in pre-calc, but I think I might have fudged something. It's been a few years since I've actually done it. Alright. So, actionable items, right? We're taking the partial fractions of s minus 2 times s squared minus 1. We can decide if we want to leave them, again, as hyperbolic sine and cosine, or if we want to split them up further as e2 e to the t. No. When we do when we do inverse LaPlace, either we're going to get hyperbolic sine and cosine by leaving it as s squared minus 1, or we're going to end up with e to the t and e to the negative t if we do s minus 1, s plus 1. So again, we can kind of decide on what we want to do there, but I'm good with it as it is. I'm good with whichever route you want to take.
Okay. I'm happy to leave him here. So.
Oh, I hope not.
And staying out of that trap.
Yeah, yep. So this is another point where Zach had said earlier that, our s squared plus 1 was irreducible. And in this case, we do have s squared minus 1, which is reducible. But still, since we're going with a quadratic denominator, we have to find the linear numerator that's going to make this thing work.
Yeah.
All right. You want to take one and I'll take the other?
Sure.
Which one you want?
I'll take D and F.
All right. could be a pain and say plus C, but... Oh. I'm over here wondering what I did wrong because I had so many terms that are like not fitting. Of course they don't fit. Boy. Let's try that again. So important point here, everybody who is following along. This is 1 over s times s squared minus 1, not just 1. That's 1. Okay, let's try that again.
Alright.
Alright, I'm going to separate the two terms here. BCE Math, thank you for the follow. And Govan. In case I didn't state it while you were here, my name is Obi-Wan Pez, and this is N Simplex Pachinko. We are doing some mathy stuff, obviously. Our Monday and Wednesday nights for the last almost 10 weeks at this point have been taken up doing differential equations. This is the same undergraduate ordinary differential equations class that I taught for probably about 6 semesters, I think. It just blurs together after a certain point. At a community college in Maryland, so thought I'd bring it to Twitch. We had also Zach at E to the 2i Pi, who over this past winter ran 2 sections of a real analysis class, and currently, question mark? Do you know, yes. Stuki? Is doing currently is doing Infinite Series, which is another class that is being held right here on Twitch. Penn Center also did a complex analysis class over the summer, and is he also planning another class soon?
I don't know. Doing the reading group for mechanics as well as for algebra.
That's right.
The mechanics one just started, so it might be of more interest.
Yep. And excuse me, Dawn Does Math also has been doing a is it electrical engineering?
ENM. More on the physics side.
Physics reading group to cover the E&M class. So we've been doing a lot of educational content on Twitch between the well, I mean, there's a lot of educational content on Twitch if you know where to look. We're gonna put, these are like our core group of 7 people who kind of got together over this past 6, well, no, it's almost been a year now. So over the past year or so, who have kind of come together and decided, hey, we want to increase specifically math content on Twitch. And a thank you for everybody's support out there who has in any way come to our channels, who has followed, who has thrown bits our way, who has just even asked a question. All of you are fundamental in giving us evidence that this is needed. Alrighty. You know, for like half a second, I was like, where'd the Matrix come from?
A bold claim. I think that's good. How that's gonna go.
What's a bold claim?
That is the correct inverse of that last one.
So if we're multiplying by e to the 4, that would be that would mean that we have an e to the t minus 2. I think.
Oh, yeah, that's correct. But then, So e to the minus 2s is going to back transform to have the f of t minus 2 in it.
Yep.
Um,
Does that leave
and
us with a constant still?
Yeah, that still leaves us with that e to the 4, which is going to cancel out that plus 2. Or, you mean that minus 2.
When it comes back in, it'll get rid of it and just make it e to the negative 2s.
Yeah.
Okay.
Question. Where did the 2 go in all of this? I feel like I lost a 2 here. The t minus 2 survived. But the 2 times t to the minus 2, not sure I'm seeing that.
Let's see.
Exponentiate. That minus 2 is this minus 2. Well, that's interesting because that suggests that this idea is not correct. So let me do it carefully. Okay. So this is fine for the first half of that. Be agnostic about how long I want this expression to be. So we'll pull out the e to the 4th and do this properly. The fact that there is an exponential out front on the LaPlace side means that there is going to be a u and a shift. So that's going to be...
That's the e to the negative 2s?
Yeah.
Okay.
So, okay, hold on. I think the 1 is what's wrong. The 1 is what's wrong. That should be in e to the 2t.
Okay. Yep, that makes sense because you're multiplying through 1 over s minus 2. Yep, okay. Gotcha.
But then that also needs a shift. Right. Okay. Well then, okay. I think it actually ends up working as I was hoping. But okay. Well,
that's all right.
Now we're
my
too
notes,
deep to.
My notes are very bogged down as well, so I'm like trying to correspond all the parts. Hey, Sensation. Good evening. Alright, so let's see if this matches up with our expectations. Let me move Desmos to my other window so that I can just look at them. Copy directly. So, don't put that down. We've got 3 cinch T. Cool. Minus Cosh T. Alright, you know what? Let's go like this. We're gonna go... This is Y1. Y'all are gonna hate me for this. Y2 is going to be -1 plus sinh of t minus 2. And then we're also doing this with t must be greater than or equal to 2. Cool, that worked. Y3 is equal to... Or did you... Okay, I see. Okay, we don't need a Y3. Sorry, what just happened?
The U2 is only attached to that term. The other one has no e to the 2s.
Right, so 1/5 times that stuff. Okay, there we go. So actually, yeah, Y3 is equal to 1/5 times the quantity e to the 2t minus such t minus 2 cosh t. Then Y4 is going to be equal to 1/5 of negative e to the 4th, also times the quantity. Okay. To the 2 parentheses t minus 2 minus sinh of t minus 2 minus 2 cosh t minus 2. Okay, so we'll bring this back over and we'll see what a mess this is. Oop, oop, oop. No, don't play that. Auto-loaded a different tab. Alright, so then we have this massive mess here, which then, if we turn all these off, and then say we want Y1. Really? Okay, fine. Y equals Y1 plus Y2 plus Y3 plus Y4. Question, does this actually do anything? Okay, cool. This is fine.
Something.
Let's see. Go from y-axis. I mean... Oh dear. It might be a bit much. Okay.
Sweep that noise off to the side.
20. Something like that. That wasn't... I don't know. Maybe that wasn't supposed to happen. Okay, so let's think, right? Our initial, it's not harmonic, so our initial stuff is actually growing. Okay, so maybe that's just the issue, really, is that this is...
Yeah, it's just growing way too fast.
Because our eigenvalues are going to be positive, negative 1. So we should get an e to the t and a negative... Oh, right, yeah. Hyperbolic sine and cosine, yes. So it's a linear combination of hyperbolic sines and cosines. I feel like, still, when we reduce the forcing function to 1, that this maybe should not go out of control.
Okay.
Alright, so now we've reached the diagnostic part of the stream.
Right. Sure. So how far off is it? The issue is that we rather would have liked...
Sensation, so the message that Punching sent was, hey Pachinko, which a lot of auto mods catch my name because it has a slur as a subset of the letters. So that may be your particular auto mod that's catching it. Mine...
No, I wrote a little message between the time that I came back and you came back.
Okay.
I'm pretty sure that's what Sensation's referring to.
Did it get auto-modded?
No, on the whiteboard, which is why. Well, it still grows exponentially, right? Even when just from the homogeneous part. Plus exponential growth. Now we might worry that maybe the cinches and the cautious should cancel, and they don't. But
yeah. Right, 2 to the e to the 2t. That's going to be... That seems like that's going to be the problem.
Right. Well...
So where did e to the 2t come from is the next question. That should be 1 over s minus 2, which we have here.
Yeah, so that's very real, right?
Yeah. Because that came from e to the 2t at the front end of all this.
That came from the 1. Yeah, I guess. That's interesting, because I was expecting it to come from the non-homogeneous part, or excuse me, the homogeneous part, but it definitely doesn't.
Okay, so let's trace it. So we get this e to the 4th, 1 over s minus 2, which goes here. e to the 4th, 1 over s minus 2. Got that here. It exists, right? So that's... We've got these two terms. So... Oh! 1 minus u2. Right, I think I didn't actually include that in the Desmo stuff. Let's see. So let's cinch
Shouldn't
cosh.
change too much.
Well, it changes what the domains are. Because I did not affect the domains on that one. So that's probably why. This was between 0 and 2.
Oh, right. Yeah, between 0 and 2. That's right.
Uh-oh.
Right. It does.
Oh no! Hey, Control Z is an excellent keystroke.
Desmos doesn't like the fact that the two functions, like y2 and y3, have non-overlapping domains. It's not interpreting them as 0 otherwise. But you can probably...
We can get around that. Somehow.
Yeah, maybe.
Oh, so I was probably starting at 0, or starting at 2. T equals 2. Okay. Wait, let's go the other way. So if we delete this stuff, and then we say y1, which is just our ascension cosh like that, is always on, then -1 plus cinch t minus 2 is only on from right from 2 onward. So we go like this. We say that it's going to be, I don't know if it's going to like this anymore, but no, it's not going to like it. Ah, there we go. Piecewise suggestion from Google, right? So that's going to be x is less than or equal to 0. It's going to be this value, else it's this value.
Yeah, it looks like that.
Okay. So we do
Now it's happy. Oh, because there isn't
greater than or equal to 2 colon this stuff else 0. Ooh. I might have done it.
Looks good.
Okay, then what was the next one? 1/5 e to the 2t, that stuff. Right, we only need the one line, we don't need the next line. Because then we say we can do a complex one here, so we don't need a complex one. Larg. 1 minus 2, 2. So we want this to be everything before 2. T less than 2, else 0. Oops. Oh, so close. You see it, right?
Yeah.
Oh.
Dang it. Okay.
We're close, though.
We're close. So it's somewhat surprising. It's that it's too small.
Does the e to the 4th show up or not show up?
The e to the 4th doesn't show up by design.
Right, so it should be absorbed as it goes back.
Sorry. Should that last cinch and kosh be 2 T's instead of T's?
These ones?
Yeah.
Should they all be? Or...
Yeah, should they all be?
So... the A value inside should be the squared value that's over on the side. So that should be one or just one.
Just one. Okay.
Yeah. Unless it was S squared minus 4.
Got it. That matters.
Let me try another
That
thing
matters.
here.
Because that means that there should be an exponent next to those sines and cosines. Because we're adding back in 4 to the exponent, but we only took away 2.
Try something randomly, or not randomly, but you know what I mean. This needs to go away. This is T greater than or equal to 2. Do that, otherwise it's 0. Alright, what else is U2 plus U to the 4th, 3. Gosh, T minus 2. Plus 2 to the 4th, 3. T minus 2. Okay. So those are my notes. It looks good.
Okay.
It's not, does not necessarily mean that it is the correct answer, but at least looks good over a short term. Right, and that's the other thing, is that it connects our values here. T equals 2. Right, we end up getting this value, 14.933. At which both sides of the function end up being the same value. Okay, cool. So, for what that's worth. Alright, so we get 3 cosh. Interesting. Okay. 3 cosh minus 1 cinch.
Yeah.
So those constants are backwards according to what I've got in my notes. Kosh has S, and cinch has a constant.
Probably both off then.
Okay, so if
Yeah.
I just trade these around in what we've got up top then. So this is a -2, this is a -1.
Cool, so you have 3s.
This is going to be a -1. This is going to be a +3. And okay. Not any closer to being resolved at this exact moment in time, but is this?
Yes, so in your notes you have 3s. I got a 5.
All right, let's hunt that down. Right, 1/5.
Could be resolved by a sign error.
Okay, so s² -1, right? S -2 times all that stuff.
Yeah, -d -2f. There it is.
So, make that a third. Well, that didn't resolve that.
And then the exponential terms, e² should be attached to
Which one? Sorry.
to the last one. To the sine and the cosine. Yeah.
So that's 2e to the
2.
So all of them?
To the sine and the cos.
Nope. Okay. Oh, hey, look at that.
Looking good. Can't see it yet.
Not so much.
No. Okay. Too bad.
All right, let's maybe switch this back the way it was. Nope. All right. Do any of those trade around?
The corrected version here is 3 out front. The -s should be a minus. Should turn into the minus cosh. And -2s. Or -2 should turn into the... -2 cinch.
So also -2 then. Yeah. Still not hitting it. E to the 2. G -2. Is it only between 0 and 2? I don't think that should matter, but no. That made it worse. Alright, 1/3. 2 to the T. 8, nope. E to the 2T. 2 e to the second cinch minus e to the second cush. And are those also T minus 2, or is that cinch and cush a T?
The second cinch cush.
Oh. No. Yeah, it's wishful thinking. Well, I think we might have to go over that a little bit more. In order to figure out what exactly happened, but that's alright.
Alright.
We'll figure it out. Alright, if anybody has any questions, please let us know. We're going to be hanging out in chat for a little bit longer here. Stuki, if you need to go, I don't know how you feel. Or what your schedule is like for the rest of the day.
Yeah, I probably should head out.
Alright, so I think we're gonna say goodbye from here, and we'll maybe, yeah, we'll talk over the weekend exactly what our plans are. I think probably this is going to be our just last meeting, or maybe we'll have like a digest on Monday, kind of
Okay.
talk about what we talked about.
Sounds good.
Any rate, hope you have a good evening.
Same back to you.
All right, thank you.
Thanks again for hosting. I'm sure we'll talk, but yeah.
Alrighty, have a
See
good
you
one.
around.
Alright, as is the case for everybody, as I've said before, ad break's about to start. Yeah, sure, we'll do a full 3-minute, and then we'll hang around for another hour. If nobody has any particular questions, or I'll again open it up to like any sort of math that you all want to talk about, then maybe we'll... Okay, we'll just go for a 1 minute then. Alright. I'll be back in a minute-ish, so see you in just a minute. I mean, if Twitch is just going to do whatever it wants to. Alright, welcome back everybody. So, here we're just going to look over the work that was done on each of these parts to make sure we've got agreement over what's going on. For my section up here, again, once we actually multiplied through by the correct values and made sure that our fraction was in fact the same, I think we're good. So negative a was 1, therefore a is negative 1, b is positive 1 because it's the opposite sign of a, and then c is 0 because there were no linear terms. Down here we had a, right, 1 equals d over s minus 2 plus es plus f over s squared minus 1. Decided to leave s squared minus 1 up. Nah, see, did it again. 1 over s minus 2, s squared minus 1. So that says that 1 is going to be equal to d times s squared minus 1, which is ds squared minus d. Cool. And then s minus 2 times es plus f, which is es squared plus fs minus 2es minus 2f is equal to 1. Cool. D plus e is equal to 0 from s squared. Right? Negative 2e plus f is our s's, and then our constants was negative d minus 2f is equal to 1. Right, so then it's linear algebra. DEF is going to be 1, 1, 0, augmented with 0. D, E, F, augmented with 0. D, E, F, augmented with 1. Dr. Gold was talking about augmented matrices last night. Okay, so we do plus R1. 1, 1, 0, 0. Alright, this is going to be 0, this is going to be 1, this is going to be negative 2, this is going to be 1. Alright, reverse. And then we're going to take... never mind. 1, 1, 0, 0. 0, 1, negative 2, 1. 0, negative 2, 1, 0. Plus 2, row 2. Minus, nope, do this one minus row 2, which Which, I mean, doesn't technically get rid of anything at the moment, but, you know, we're getting there. It's going to get us a 0 here and a 2 there. A -2. It's going to be 0, 1, -2, 1. This is going to be 0, 0. Plus twice the above. It's going to be plus a -4 is a -3. And -2 as well. Minus 2/3 row 3 plus 2/3 row 3. 1, 0, 0. Alright, so this is a -2. I'm getting much larger numbers. Well, that's no fair. Oh, wait. No. Now we're good. Alright, 2/3 is 4/3. That's making it... That's reinforcing. 10/3? Nah, there's something wrong there. Hang on. Must have copied something wrong, because that doesn't... That's not going to work out. It's going to be a 1 plus 4/3. So maybe like 7/3. This is going to be a 1 is going to make this a positive 2/3, and this definitely doesn't add up because D and E are not opposite signs of each other, so that's not going to work in the first place. And I really messed this up. D, E, F, constant. D, E, F, constant. D, E, F, constant. There's that. Right. We want a 3x4 matrix. 1, 1, 0, 0. 0, -2, 1, 0. -1, 0. -2, 1. REF, matrix A. Yeah, no. Oh, man. No, Stucky definitely did that one right. Alright, D is a third, E is -1/3, and F is -2/3. Cool. I just really messed this up. Plus row 1 knocks out the bottom row, gets us that. Hey, Walrus. Are the equations differentiating? Somewhat. I messed up real bad in this somewhere. Oh, yep. Nope. Nope, never mind. +2 row 2. Okay, there we go. That's supposed to be a +2 there. Yay! Right. So a 2/3 of row 3 is going to be 4/3 minus 6/3 is going to be a negative 2/3 at the top. Right, that's not... no, hang on. Alright, 1, 1, 0, 0. 0. 1, negative 2. 1. 0, negative 2, 1, 0. Repeat. Same values, so therefore that matrix must be the same, or at least equivalent. Alright. 1, 0, 2, negative 2. 0, 1, negative 2, 1. 0, 0, negative 3, 2. Nope. All right, somewhere between this step and that step. Okay. That should do it. That should be a -1, which we're going to add 2/3 of row 3. Here we're going to subtract 2/3 of row 3. Okay. Add 2/3 of row 3. 2/3 of 2 is going to be 4/3 minus 1 is going to be plus 1/3. There we go. Alright, minus 2/3 is going to be minus 4/3. Off of 1 is going to be a minus 1/3. And then here divide everything by -3, so we get a negative 2/3. Cool. Alright, that's better. Okay. So with that, let's guess us. Need proper bookends. Not just a giant stack of old games magazines. And yes, that is in fact my bookend at the moment. That is my enhanced certificate, which allows me to go on school field trips with my kids. Tensor calc. standard copy of Love Triangle. Oh no. Please tell me this did not break. Whew. Alright. My grandmother got me this when I graduated college. I've showed it before, but... this fell off my desk, so I was lucky. But it's an apple with, like, gold leaf floating in it. She's always been really big into, like, trinkets and stuff like that. Yeah, us, not so much. But I've always kept it at my desk because, you know, reminds me of her, reminds me of all of the various conversations we've had since I was, you know, real little, just talking about how my only interest was Nintendo. I think she might be slightly proud of the fact that I had some sort of direction in my life. Lol. And here we are. Okay, so 3s minus 1, it gets us our 3 cosh t minus cinch t, right? Okay, the negative s minus 2, so it's a negative s plus 2. Ah. Cosh is s. So, in the one case, we end up with a 1 cosh minus 2 cinch. So you had it right the first time, I think. Two cinch, 1 cosh. Yeah, okay. You already had that. Okay. The original cinch cosh should have should these be differentiated? And by that I don't mean using calculus. Right, because these are not 1 and minus u2. These have the t minus 2 as an argument separate. Damn it. Should have realized that while you were still here, Stooky. Apologies. Alright, so from 0, we should have had this stuff. So it's t greater than 0. This. And then there should be a y4 in there. Y4 is equal to, and this is where we say this is where we say when t is less than 2, we're going to have, this is almost identical, so let's just copy paste everything that's in here, but then, right, but then we're going to say that this is going to be T, we don't want this to be graphed, we just want the red one. These are all going to be -2, -2, T -2. Okay, and this is going to be a -1/3, I think. Oh, so close. What's going on here? That all needs to be shifted up. What's off? What's off? E to the 4. Ooh. No idea where you went. No, I could see the overlap. Right here. Right. Is there still a jump? What's going on? It includes e to the 2. I might have just fixed it. Of course, it's into the negative region, so I have no idea why that's happening, but you know what? One step at a time. This is doing alright. Nope. Got a gap. Well, that's unfortunate. Cosh negative sich. Plus. 1 plus cosh t minus 2. We go from 2 off. E to the 4th doesn't apply to this stuff. Ooh. Oh. Do it. Oh, it's looking like it does it. Oop, nope, not that one. I just maximize the screen. Okay. So, doesn't look like the same thing that I got in my notes at school. However, it does look continuous. So that's a plus. Okay, second is this. This is when U2. So T is greater than or equal to 2, also compared to the other one. And then else, this is 0. So -1 plus cosh g minus 2. Okay. Now, if we add this, if we add z2 onto the end of this y, nope, not any better. Well, that was worth a shot. Got my hopes up. I missed a term somewhere in all of this, so I was hoping that was it, but apparently not. Okay. Well, we're just gonna have to play around with this more until we figure it out. It's closer, but it's not any better. Yeah. All right. So I think we're going to call it here, unless anybody has any particular questions about mathematics that you would like to talk about. What day is it? It's Wednesday. Belint is going to be on. You know what? He's probably going to be on in like 10 minutes. So I think we should just... Oh, punching. I'm sorry. Yes. Perfect timing. Yeah, I think Belint's going to be on, and I think after your question, or if anybody else has any, we can pop on over there. All right. Shock! There's something new in the maths form. A particle is located a distance x meters from the origin. A force of cosine of pi x over 3 newtons is going to act on it. How much work is done in moving the particle from x equals 1 to x equals 2? Interpret your answer by considering the work done from x equals 1 to x equals 1.5 and x equals 1.5 to x equals 2. Okay. So the way that we're going to look at this... Hey. Riffiel, thank you very much for the follow. So the way that we're going to look at this is, right, what is work done? How's things? So yeah, punching, how do we do work in terms of, I'm going to guess this is like calc-based physics, or it was in your calculus class, one or the other. Goodness. Yep. And not just lowercase f of x, uppercase f of x, because we're talking about the force that's being done, not just any old function. Although, realistically, yeah, sure, you could also say that. Alright, now the reason why this all works, right, our individual work that's being done at any one motion during any one time period is going to be the force over that same time period times the distance over that same time period. So this is going to be x sub I minus x sub I minus 1. Which we could also say is going to be f sub I times delta x sub I. Most of the time our delta x's are the same thing, but whatever, it's fine. Yeah. And then we're looking for the limit of the sum of all of these things as n goes to infinity, I goes from 1 to n. Right, which then feeds back and shows us, oh look, it's the integral. Right, so that's an important little thing to be able to explain the second part of your question, that if you're splitting it up over subintervals, then you're going to look at what happens to the sum of the work that's being done over any given specific time interval. Then for this was, how's this going to work when we do, where'd it go? Right? Cosine of pi over 3 times x. Okay. Times dx. Going from 1 to 2. Alright. So what do you got so far? Like, if this is Calc 2 you're talking about, 99.99999% of them are going to be done like this. That's me pointing with my mouse. Are going to be done like this. You start with, how do you find the first slice, then take the limit as n goes to infinity of all possible slices between those two limits of integration. So every single problem that you're going to encounter in Calc 2, like, that's talking about, you know, what is the blank, all of the physics, all the applied problems, how much rope is being pulled up, if the, you know, amount of rope that you're pulling, if the rope itself is weighted, like, all that stuff. That's this. So it's always going to be finding an integral, but how do you find the integral? It's going to be individual slices that then get stacked up over an infinite amount of slices. So if you could figure out the, like, lower formula, you can figure out the integral. It's just going to take you a little bit to maybe run through this, you know, limiting stuff. But, yeah, that's what we get now. So I'm not going to be doing another math stream until Tuesday, but maybe Monday, we'll see. But several other people are going to be on later tonight / tomorrow / Friday. I believe Dawn, Stooky maybe, and Penn will be on at different points. Probably also Zach, but I don't know. We'll see. I can't remember. If you check all of their individual Discords, yeah, Dawn's playing video games tonight, but like over the next few days. Yeah. So anybody else out there who has not yet seen this list, this is the 7 kind of core people who came together and first said, hey, math on Twitch sounds like a good idea. And tried to, like, organize some sort of group getting together, all that stuff. There have been plenty of math streamers on Twitch before us, and there will be plenty of math streamers on Twitch after us. But nonetheless, in this exact moment, we are trying to get all of us and as many other people as possible all together to try and organize some sort of, like, edu math on Twitch. Try to create that space. Nice. I know Dr. Gold usually does like SAT work, but he would actually also be somebody to go to his stream and just say, hey, I've got this question, can you help? Because even if he's not technically able to answer something, and believe me, he's done plenty through Calc 2, but even if he's not able to answer it, he can just ask stream and then help. Oh yeah, no worries. I mean, all of us are here just because we like doing it. So, like, even if y'all weren't here, like, I'd still be doing math on Twitch. Might feel discouraging at this point if there was nobody. But hey, we got 503 people who think it's a pretty cool idea. So alright, so Punching, do you know how to do the rest of this one from here? Okay. Me personally, yep. I like calling this a U substitution, even though it's not necessary to call it a U substitution. Just because it's convenient for me to state that it is. Alrighty. If anybody's got anything, let me know. Got any questions about math, about Twitch, about math on Twitch, about teaching math, about learning math, you name it. That's also another question. Is TwitchCon going on? It's tomorrow. Okay. Some people might be traveling then. Yeah. Hmm. Who? Okay. I know Pirate Software, I know Meg Kaylee. And Science, yeah. Okay, so Boleyn's probably not going to be on tonight. Who else? No, don't know anybody else. Sunday afternoon, Science and Tech Community Meetup. That sounds fun. Okay. Phasmo for real, paranormal investigation streams. Oh god. Yep. Alright, well, let's see. See if we got anybody different at the moment. The other day I had a lady walking by and I was like, you know, trying to explain like, are you here to pick up a child? Because she was walking like on the property of my kid's school. But you know, I was just like, are you here to get somebody? And she was just like, and I was like, oh. And then she started speaking in a completely different language. And I was like, ah, okay. Like I know it's kind of in the family of like Russian-derived languages. So I was like, Ruski or Ukraini? And she's like, Ukraina. I was like, ah, okay, cool. So I tried asking her again, like, in Ukrainian. I do not speak Ukrainian. I speak not a word of Ukrainian. But I tried, like, typing it on the phone and then attempting to read it. Like, hey, so this is a school. Are you here to pick somebody up? We did not understand each other. She's probably like, who is this guy and why is he here? Alright, I think tonight we're gonna go see... I think we're gonna go see Stephen Joyce, who is playing a game, but it is called Valley Peaks. I don't know what it is. It looks rather interesting, and we have not, I know, right? Oh, come on now. Where are my emotes? There we go. Alright, so let's attempt to make this work. I think this should work. So if we... yes, thank you for making that. If we copy this, it should work, question mark. Anybody who wants to try it out, let's give it a shot. And... gonna go see Stephen Joy. Ah, he went offline. Of course he did. All right, seriously, let's refresh the page, because who knows how old it actually is at this point. Alright, let's do Domestic Dan. We're gonna run over to his channel. He's got Satisfactory, attempting to build roads. So, I will see you all on a Friday, probably, is the next time, unless I find you in somebody else's stream. So, have fun, good luck. If you need to ask any mathy type questions, feel free to connect with me, either direct message, go on to Penn Center's server, what have you. I'll try and be slightly more active over the next couple of days, and hope you all have a good couple of days. Go, have a good night.